All right. Well, thank you very much. Thank you very much for giving us the opportunity to present today. I'm going to talk this afternoon about a new system that we have developed as LSI Lastem, that is a remote sensing system for the monitoring of the structural integrity of tailing dam. Well, actually, it's the application is actually more than just tailing dam monitoring, but this evening we're going to talk about tailing dam remote sensing. So the name of the system is Greta. Greta is an acronym for Geo Resistivimeter for Time-lapse Analysis. Just a couple of words about LSI Lastem. The company has been founded in the early 70s. We are headquartered near Milan in Italy. And among other things, we are an ISO 17025 accredited laboratory. And although we are not a huge company, we are pretty much vertically integrated in the sense that we have pretty much all in-house from research and development, production, and after-sales services. What do we do? Basically, we do environmental monitoring equipment for different types of application. The traditional ones are meteorology, hydrogeology, renewable energies, waste management cycle, microclimate, health and safety, and indoor environment. And a couple of years ago, actually, at the beginning of last year, we entered a new field, which is the geophysics with the Greta system that I'm going to introduce you in a moment. So in our product range, we have a variety of data loggers, different types of sensors, and signal converters and software. And Greta is, a new add-on in our product range beginning of last year. So what is Greta? Greta is basically an off-the-shelf industrialized remote sensing solution for the permanent geoelectrical monitoring of the conditions of large sections of soil. The system has been developed in collaboration with the Politecnico di Milano, which is probably the best engineering university in Italy. What does it measure? Basically, the Greta system measures the modification over time of the soil's resistivity profile. And the main characteristic of the Greta system is that it is a fixed system. It is energetically autonomous, as we will see later on, and it's also permanently connected to a cloud software. So thanks to the Greta system, it is possible to monitor over time the evolution of the resistivity profile of a given soil, to assess the evolution of the water content, the triggering of possible infiltration, the triggering of possible landslides, or the triggering of fractures or pollutants contamination. And when preset thresholds are reached, alarm messages may be automatically sent. So I have here a short video that explains in synthesis what the system is all about. We're gonna go through the video and then we will take it from there. So this is an application of the Greta system on an earthen dam. The system is composed by IP6 box, solar panel on top, and inside the box there are the different modules that constitute the system: measuring unit, communication unit, the battery. Then the boxes are connected to 2 cables with 48 electrodes altogether. Then there's an electric field generated. So the system is permanently connected to a cloud software, and so from the cloud software it is possible to keep monitoring over time the evolution of the resistivity profile, and if there are changes of resistivity, then an alarm message may be sent. Possible fields of application, earthen dams monitoring, levees monitoring, linear infrastructure monitoring, such as railways, landslides monitoring, pollutants contamination risk protection, and also we have an experience with the precision farming. Okay, so let's go through again a little bit the possible fields of application. Actually, the most important application is in the monitoring of earthen dams, and tailing dam being one particular application. Greta, after me, will go through a presentation about the experience we had with the installation of the Greta system in one of the largest mines in tailing dam over largest mines in Chile. Another possible application is in the monitoring of levees, and actually this is where the initial concept of the system started. Or the monitoring of the soils contamination in waste landfills. I'm not gonna go through the fundamentals of the technology, which I know that you are very familiar with. All I would like to say at this point is that the tomographic inversion of the data, which obviously is fundamental to obtain the two-dimensional or three-dimensional reconstruction of the resistivity profile of the soil, in our case, is done automatically in the cloud software. Yeah. So here are the main components of the Greta Geo Resistivimeter. So actually in a single IP66 box, there are the different modules, the power unit, switching unit, processing unit. There is a 4G modem router. And on top of the pole, there is a solar panel. In terms of technical features, the system comes with 2 cables with 48 electrodes. This is a fixed number of electrodes. What can change is the distance between the electrodes, in the sense that we can supply cables with different distances between the electrodes, up to 3 meters. In this case, with 3 meters distance between the electrodes, the maximum measured profile length is 141 meters, and the maximum measured profile depth is 22.5 meters. We use a Venner configuration type. The power is granted by a solar panel, but obviously if there is availability of a power supply, the system can also be connected to the electric grid. The communication is granted by a modem router, and not only the visualization of the measurements, but also the configuration of the system and the programming of the instrument is done via the cloud software. And in the cloud software, there is also an alarm management system based on configurable thresholds for each specific soils area. On the cloud software, I'm gonna come back in a minute, and also Greta will give you a little demo about the software. We have foreseen two types of installation, horizontal and vertical. In case of horizontal installation, we offer two different types of electrodes, plate electrodes or rod electrodes. We use plate electrodes in case of a permanent horizontal installation. In this case, the cable is completely buried inside a 40 centimeter deep trench, and obviously once the cables are covered with the earth, you know, they are no longer visible. Whereas if there is the need of a temporary installation, let's say for you know, a monitoring of you know, weeks or even months, and then you know, you needed to reposition or relocate the system into a different location. In this case, we can offer and we can supply cables with rod electrodes, and in these cases the cables remain on the surface of the soil, and it would be a lot easier to reposition the cables. We have also foreseen a vertical installation. In this case, the two cables are placed inside a borehole. So you know, in this case, in a case of a vertical installation, through the system, it is possible to monitor a volume of soil, which is basically a double cone with the maximum diameter at the center, at you know, in this case at 72 meters, and the first you know, the first cable will have the electrodes starting immediately from the surface of the soil, whereas the second cable would have the first electrode starting at the end of the last electrode of the first cable. Okay, as I said, the system is permanently connected to a cloud-based software. From the software, it is possible not only to visualize all the measurements, but also configure the instrument, and Greta will give you a little demo. But just let me highlight a couple of you know, important features about the cloud software. From the software, you will be able to basically see all the different resistivity measurements that the system has done over time. From the system, it is also possible to make comparisons between between the resistivity profile of any given time interval. So, you know, you can compare the resistivity of today with the resistivity of 1 week ago, or a month ago, or you know, back. You know. In this visualization, you can see that the third chart here is actually the difference between the resistivity value of the two measurements. All the data can be easily exported in to you know, any other software, and so the data are easily exportable in CSV or in JSON format. Actually, we are also working with some specialized geological software companies for an automatic export of the measurement into their specialized geotechnical or geological software. Another important feature of the system is that it is possible to calculate the volumetric water content of the soil, and you can do that after a calibration, and Greta will talk to you about this in a moment. So Greta, would you like to take it on from here and
Yes.
and go through the demo of the software?
Maybe while Greta is setting herself up, we could, if people, just a reminder, if people have questions for either Andrea or Greta during or after her talk, feel free to post it in the chat section, and then we'll read them out loud. Looks like you're already ready, so we'll let you go, Greta.
Okay. Can you see my screen?
Yes, you're good to go.
Okay, perfect. This is the home page of the cloud software. Here you can see the map with the systems that belongs to the user. So here the user can see different points that are the exact position of the system. And there is a first diagnostic tool, since the point is colored thanks to a traffic light. This traffic light can show, for example, if everything is okay, so in this case the point is green, or if there is some warning or some error with the instrument. Then the user can obviously see the data, can go to the chart section, and here there is the inverted resistivity section. The user can select its system, and also if he has multiple stations or multiple sections, can select the one that wants to see. And it's possible to go through the data of different dates. So using these arrows, it's possible to browse through a calendar and go and see the different dates. Then the user can change obviously the minimum and maximum value of this the scale, and also can lock the scale to have an homogeneous color range through the different dates. It is possible also to compare measurements from different dates. So enable the comparator. The user can select two, for example, these 2 days. I can see the 2 sections and also the section of difference. So for example, in this case, the situation is really constant and there is a little change that is more or less equal to 0. The user can also see the raw data, so can see the apparent resistivity values, selecting this tick, and also all the parameters that are related to the measurements, so the injected current or the measured voltage, or also the standard deviation of the measurements that are a really important tool to control the data.
The quality of the data. Yeah.
The quality of the data. Okay, so this is, for example, the standard deviation of the one measurement that is more or less equal to maximum 0.4%. So really good quality of the data. There are also some graphical settings that can be selected. So for example, the scale can be changed from logarithmic to linear, or also the chart type can be changed from heat map to isolines. So for example, we can see the inverted data through the isolines. So I can select the resistivity, the inverted resistivity of 1 day, and I can see the graph through isolines, for example, if some user prefer to see this kind of graph. Then here there are 2 buttons to download the data in CSV format or JSON format. We are working also to improve the software in order to include meteorological data. Since we are manufacturer of meteorological sensors, we are working to include this value also with resistivity data. And the next improvements will be to include also piezometric data and to see them on the section in order to correlate the resistivity to the water table. Another important feature, a diagnostic tool, is the contact resistance test. That is really important to see if the electrodes are good coupled with the soil. Since this instrument is working remotely, it is important to perform, for example, every week or every 2 weeks, a remote control of contact resistances. Also here, the user can select the date of interest and can control the resistance value of every electrode and see if they are good coupled and if they are working well. This software, cloud software, is useful also to configure the system and not only to see the data. So the user can schedule the tests, the resistivity measurements or the contact tests, and also can decide the frequency of these measurements, and then modify the parameters and send the new configuration to the device. Here we can see the survey in settings, so the vendor configuration, the number of electrodes, and so on. This cloud software is really important. This part is really important, is the configuration of the alarms. So the user can select his system and can decide to create a configuration to start an automatic control to send alerts when predefined thresholds are passed. So the user has to put a name of this configuration and also the email address of the person that is in charge to receive the mail when these thresholds are passed. Then the user can decide a different kind of thresholds of alerts based on the zones of interest in the sections. So, for example, I can decide to consider only a part of the section and to perform this control only, for example, in the central part of the section. I have to put the name and the threshold of percentage change of resistivity. So in this case, I have 80% when the variation between two sections of different days change of 80%, I will receive an email. And here some settings about the radius of control of the zone. So for example, a radius of 2 pixels. And then I can also decide different temporal distances between this control. So in this case, I have 10 days. So the resistivity section of today is compared with the one of 10 days before. In this way, I can, for example, see small changes that are accumulating along the days. I can also select, for example, 2 days. So the section of today is compared with the section of 2 days before, also, for example, to see fast changes. I can save the configuration and enable it. Then there is a part of archive of past alerts, and also a user management tool where the user, the company, can decide all the people that can access the data. This is a short overview of the software. Now I want to show you a presentation about a test study that we had last year in Chile. And also I want to speak about some technical implementation that we implement in the system to have a real high quality data. Here there is a short summary of what Andrea told before. so the main feature of the system. And here I will go through some important technical implementation that we decided are really important to obtain good data. So, for example, one important thing is to decide which kind of electrodes use in an installation of long duration. So we usually use plate stainless steel electrodes, but we wanted to test also the mesh electrodes, because we know that the mining environment is really harsh, and we wanted to make sure that the plate electrodes were good for this purpose. So we made a test and we compare the plate electrodes with the mesh electrodes. Our test was installing 11 stainless steel plate electrodes with a distance between electrodes of 1 meter, and we buried them inside a 20 centimeters trench. The first 5 electrodes were big plate electrodes. You can see them here. While the last part of the profile from 6 to 11 were small plate electrodes. We wanted also to test the variation of contact resistance with different shapes of electrodes. We took an experiment of 7 hours and we measured the contact resistance every 1 hour. We made the first measurements with all plate electrodes, and then after the first measurements, the baseline measurements, we changed the electrode 2 and 3 with mesh electrodes. What we saw was that the bigger electrodes obviously had a low contact resistance, while the small electrodes had higher contact resistance. Here there is a zoom on the behavior of the contact resistance test of the 2 electrodes that we substituted. So electrode 2 and electrode 3. After the first measurements, we substituted with mesh electrodes, and the behavior was a little bit strange. So we had, for example, a rising of contact resistance for the first measurements, and then a gentle variation, but the variation was not so great. So the contact resistance were more or less the same. And also in the other case, the contact resistance after the second hours were lower, but with not a great variation. So we decided that the plate electrodes that we have always used were the best also in case of mining environments. And then we implemented also a variation in the low level measurements. So in the injection of current, in order to have stable data, we introduced the plus to minus plus method for the injection. That the objective of this kind of injection of current for each measurement is to suppress the low frequency variation in background spontaneous potentials, because we had filters to remove spontaneous potential in the soil, but with this new kind of insertion of current, we removed also the linear spontaneous potential, because the current injection may consist in a positive injection of current, a double negative one, and finally another positive pulse, in order to remove with this filter, with this average of voltage, the spontaneous potential with the linear trends in the soil. We implemented also the Focus One protocol for contact resistance measurements. The objective of this protocol is to measure the true single electrode contact resistance, because the resistance is measured between the focus electrode, so one, and then the second, the third, and all the other electrodes connected in parallel. And the measure in this way is dominated by the contact resistance of the focus electrode. We decided also to vary the measurement sequence in order to avoid the polarization of the electrodes. So we always, we don't want to use an electrode that before was used to insert the current after to measure the voltage, because this can create polarization of the electrodes. So we studied the sequence in order to avoid this scheme of insertion and measurements with the same electrode. And as we insert the electrodes inside the soil in a trench, we also insert a formula to compensate the depth of burial of electrodes in the soil. Here is a slide to explain how the calibration of the soil water content is done through the software. This kind of function that links water content and resistivity is a site-dependent function. In order to calibrate it, the user has to make a core in the site, in the study site, extract samples along that, and study them in the laboratory in order to obtain the gravimetric water content. Then, as the gravimetric water content is known at each depth, and also the resistivity is known through the measurements that we perform in the site, it is possible to extrapolate this curve, that is a potential function, with two parameters that can be inserted in the cloud software that can automatically convert the resistivity images in water content images. Here, the study case that I told you about the installation of the Greta system in one of the largest mines in Chile that we performed in the 2020, last year. The site was a downstream tailings dam, and the aims of the monitoring with the Greta system was the phreatic level monitoring through G.R.T. measurements below 2 wastewater ponds, and then the comparison of the G.R.T. measurements with piezometric measurements in order to correlate the variation of the wastewater pond level with the variation of the groundwater. We performed 2 monitoring, medium-term monitoring campaign. One was profile 1 of about 2 weeks through August and September 2020. The profile 1 was parallel to the underground water flow, while the profile 2 was more or less perpendicular to the flow, because there were some topographic variation that didn't allow us to put the profile exactly perpendicular. Also, this profile 2 was put in place for more or less 2 weeks, and in the site there were 3 wells, and we could compare the variation of the groundwater level with the measurements. Here are some photos of profile 1, so the system that was installed in the site with the solar panel. This is the cable, and the electrodes were road electrodes, since the installation was a medium-term one, with the spacing between electrodes of 3 meters. Here, the position of the wells. Other photos of the profile 2, with the always with the spacing between electrodes of 3 meters, and the position of the wells in the site. We studied also the variation of contact resistances in the site. You can see the black line that was the first measurements of contact resistances of every electrodes. And you can see that more or less the contact resistance was okay, excepting for the last part of the profile. After hammering this part of the electrodes and also pouring salt water on the electrodes, you can see the green curve with a better contact resistances. After the 2 weeks period, the contact resistances were really good, of more or less 1 kilo, also because there was rainfall that enhanced the coupling between electrodes and the soil. Here are some images of the standard deviation of the measurements, the first day and the last day of the profile one. You can see that the standard deviation was really good. You can see here a line of higher contact resistance that was low, but higher in respect of the other parts, due to the bad coupling of the last part of the profile. Here you can see an image, a section of profile 1. The identification of the aquifer was really easy after below this resistive part. And here along the profile there was a piezometer, and the measurement of the piezometer that where the water table was at minus 8.5 meters was perfectly matching with the measurements of resistivity. Here are some slides about the variation of the height of the water table. The variation was not so huge, so it was more or less of 1.5 meters during the period of study, but you can see here the position of the piezometer, and you can see the variation of the ERT data along with the variation of the height of the water table. So from the first day, you can see that the height of the water table was rising, so also the variation of the resistivity, where the conductive zone became more higher until the end. So in conclusion, this technical implementation on the Greta systems results in high quality data. This implementation were the study on the mesh electrodes that then were discarded in favor of the plate electrodes, the plus to minus plus algorithm that gave more stable data, the focus one protocol that was introduced to measure the contact resistance. The sequence was modified to avoid the polarization of electrodes, and also an automatic depth compensation was implemented. This first installation on the Chilean tailings dam was successful and provided good and high quality data to be related with the phreatic level. The contact resistance were testing along all this period, and were lower during the installation through pouring salt water. The standard deviation were really good, and the piezometric data matched ERT data. I have finished this presentation.
Okay, and I just wanted to conclude, maybe, if I may, my presentation. Okay. Yeah, well, obviously, because it's, can you see my screen?
Yeah, you're good.
Okay, good. Because it's a cloud software, it is possible to visualize the data from any kind of mobile device, including smartphones. One point that I would like to highlight is the fact that despite Greta being an off-the-shelf monitoring solution, it actually guarantees accuracies which are really in line with the ones of the best commercial portable geo-resistivimeter available in the market. And we tested a number of times, the measurements of the Greta system with the one of the best portable instruments, and they have always been extremely good matching of the measurements. As as Greta showed, we can also integrate the resistivity measurements of the soil with environmental measurements such as rain or temperature, humidity, and also with the measurements of the piezometers, and these measurements can also be integrated in the cloud software. So in conclusion, Greta is an off-the-shelf remote sensing solution for the geoelectrical monitoring condition of the subsoil for different types of application, earthen dams, tailing dams monitoring, levees, earthen embankment monitoring, or soils contamination risk protection. It's a totally autonomous system. It's very, very easy to install. You literally place it in the field, you bury the cables and you turn it on. Automatically, you see the data inside your cloud software. Does not really require particular maintenance, and it allows the continuous geoelectrical monitoring of largest subsoil section and the effective management of early warning. So in a way, Greta system is trying to make geoelectrical monitoring made easy. That's all. 45 minutes. I guess this is what we were allowed. We will be pleased, obviously, to answer any kind of question. I believe there is already one in the chat. Have you looked at other arrays beside the Venner, such as pole-dipole or pole-pole, and possibly in combination to get greater depth? Would this be possible with the present configuration of the system? Greta, you want to take this?
Okay. We decided at the starting phase of the project of using the Venner configuration, since it is more robust against 3D measurements, 3D effects. So as we started our study on levees, and also this system can be used, for example, in dams, 3D effects can be really, really strong. Many studies prove that the Venner configuration is more robust, and so we started with this one. Nowadays, it's not possible to change the configuration, but probably in the future, it will be possible.
Yeah, thank you for this. You clearly thought through a lot of details. It's really impressive. You're taking geophysics in the 21st century. There's no doubt about this. Thank you very much. We have another question here from Peter Kowalczyk,
about spontaneous potential measurements, SP measurements.
Oh, that's right. That's the another one. Yeah, if you want to answer this one.
Okay. Info.
Basically, instead of using a controlled source to just measure the cell potential, yeah, if you ever encounter this.
Okay. This device is not designed to measure also SP data, but only resistivity data, DC resistivity data. I know that the SP are really, really useful in the case of water flows or leakages, but the Greta system is designed to perform DC measurements so far. Are there plans to incorporate a higher power transmitter to allow larger separation, greater depths, and longer lines as required for many large tailing dams? Yes, the further implementations and also modifications.
Let me try to address this, Greta, sorry.
Okay.
Well, obviously, when we designed the system, there was always a trade-off between the importance of having a totally autonomous system, because this is what, I think it was important to achieve, a system that was autonomous and not needing, to be connected to a power supply. We reached this trade-off where we can inject up to 400 MA, and this is somehow the limitation of the system. Nevertheless, and so should somebody need to cover a longer monitoring profile, basically the customer has to put more units one after the other. Okay, and in this case, you can achieve a longer monitoring span. We do have some ideas to actually go longer and deeper, but this issue of having a trade-off between being energetically autonomous and going further down and deeper, it's always there.
So would you say that most of your clients are using the basic system, or you get customized? Basically, people are asking, is it possible to get souped up version of your system, or are you mostly focusing your business on the current?
No, at the moment we are really focusing on the existing system, which is as I said, we can provide a different length of cables, with different distances between the electrodes. Again, the limit is also depends also by the resistivity of the soil. If you have a soil with very low resistivity, probably you can even go longer than just 3 meters. Of course, you lose a little bit in terms of not accuracy.
Resolution.
Sorry? Resolution, sorry. But the moment the limit is this 400 MA maximum current injection. Greta, you want to take the other one?
Okay.
What is the frequency of the system?
Okay. Yes, the injection of current lasts usually 250 milliseconds, and the complete cycle of measurements of all the 48 electrodes is more or less, it depends on the soil, but is more or less than half an hour. Then there is the automatic inversion that is really fast. It takes 1 or 2 minutes, and also just after having completed all the measurements, the data is inverted and is on the cloud software. Then what about induced polarization? Yes, it's for sure a really important measurement. And as I told you, so far the system is designed only to perform DC measurements, but I don't exclude that in the future the induced polarization can be also measured, because the hardware is more or less the same, and so can be in the future it can be studied. What is the typical amplitude of current being injected? As Andrea said, the maximum current injection is 400 milliampere, but obviously the typical amplitude of current being injected depends on the soil characteristics, but the maximum is 400 milliampere. A possible application is monitoring the operation of leach pads, as this can develop a lack of porosity and fluid channeling, and hence a failure to extract all the metal in the pad. A series of resistivity histories for leach pads during their operation might be quite useful. Yes, for sure. This process can be monitored through time with this kind of measurements, since the variation of resistivity a long time is important.
Our audience is obviously a little bit more mineral or mining focused, right? So that's why we're looking to different applications. I have one question. So you tested your electrodes, right, over a period of 8 hours. That's what the test was showing. How does it look, for instance, for Peter's comment? If you're going to do it over, months or probably even years, like how does it look in terms of changes in receivers and all that?
Yeah. Are you speaking about the contact resistance?
Correct. Yeah. So is your measurement changing quite a bit over time?
Yeah. Yes, we did this test with mesh electrodes only for this one day, but we have a series of data of contact resistant tests for years, since our first prototypes are still in place from 2015, and we
keep measuring.
Frequency. With a certain frequency, we perform also contact tests. And I think that the fact that the plate electrodes are placed inside the trench that is buried is a really good way to install a permanent system, since the soil is compressing the electrodes. And with the passing of time, the soil goes more and more, gives more and more pressure on the electrodes. And so the contact resistance are always good, also after years. In our case, in our pilot sites, obviously the mining environment is quite more harsh and dry. But in our cases, the contact resistance tests were really, really good.
And for maintenance, let's say you have to go back and, I don't know, clean up the electrodes or move the cable or whatever, is it complicated to recalibrate your system, or is it fairly, I don't know, by experience? What's your take?
In our case, we left the system in the remote place, and probably we have to go there only to, for example, if we want to make some comparison measurements, or to change the battery, for example, every 2 years, or to clean the solar panel, but the maintenance is quite low for this system.
The whole idea about this Greta system was to develop a very standardized off-the-shelf monitoring solution. Geo-electrical monitoring has always been, somehow belonging to very specialized people and complicated to it. This is a very standard approach, and so the idea is to give the opportunity to use such monitoring system also to people that are not necessarily super specialized geophysics. So that was the challenge in a way, and I think we reached a good result. It's a very, very simple system, and it's there's very, very standardized in a way.
You want to read the Greta question? Yeah, I'll let you read it.
Yeah, another question about the if we use the joint inversion of resistivity data and piezometric data, or if we simply provide comparison to these other data sources in the visualization software tool. We want to include the data that comes from the piezometers, and only to visualize them on the resistivity section. We think that is an important information and having all this data in different softwares can be misleading. For us, it's really important to have a simple comparison tool, not something really elaborate, not a joint inversion, but to invert the data and then to put the value of the piezometer on the graph of the resistivity measurements. Superimpose the two images in the exact position of the piezometer, obviously.
And I guess the user can always take the data out and do more advanced processing after the fact, yeah?
Yes, because the user can export also the raw data. So if the user is an expert and wants to use other more complicated software, geophysical software, can export the data and treat them in another environment.
And quite interesting also, you have an automated trigger for warnings or emails you know, to the user. I guess you could possibly trigger other systems like irrigation valves or whatever other, you know, instruments that are attached to this measurements. If any of your users have used this?
Can be an implementation.
Right.
We haven't thought about it yet. But,
yeah.
If you send an email, you can send a trigger.
Study case.
That's great. I'm not seeing any other questions. If people, there you go, Graham. You want to ask a question?
Oh, hi. Thanks, Andrea and Greta, for giving us a great window into monitoring of an important issue. We in the geotechnical world will really benefit from having always on geophysics. And I think it'll lead to a lot more implementation of geophysics for this important aspect that has not really been taken up yet by the mining industry. So I know that at Clone we have a significant amount of interest from some of our engineers. So we'll be in touch, as I imagine other people that have heard this will be. So thank you very much.
Well, thank you for giving us this opportunity. And needless to say that should you be interested to deepen this the application of the Greta system in any kind of project, we would be extremely pleased to cooperate and try to support this project.
On that matter, have you got a distributor or a dealer or an association with a service company in Canada, and have you reached out to the American market for heap leach and all those sorts of things?
Not yet. As a matter of fact, if you guys have somebody that is interested in taking on the distribution in Canada, we would be pleased to. We are taking again, this is quite new, and actually the COVID did not help, as you can imagine. The launch of this product. We have taken agreements with people in South America, in South Africa, partially in Australia, but not yet in Canada. And obviously, if you guys get to know somebody that would be willing and interested to take on the distributorship, we would be happy to collaborate. Think that the installation in Chile, we were not physically involved. Because of the COVID, we could not go there, and so we simply shipped the system, and the system has been installed by a distributor without our physical presence over there. This is to say how simple is the system to be installed and to be set up and configured. So, but obviously, you need some installation, and you need a distributor to do the installation. Sure.
You provide the Allen key.
You
provide the Allen key to make the build it.
Sorry, it all comes in a flat pack. No.
Yeah, exactly. Well, on that note, we just passed the hour. So if no one has urgent comments, we can, I'm sure, reach you on your through emails, and with your agreement, we'll be posting this video on our YouTube channel, so you can reroute it to whoever you want.
Please.
People can watch it later, also in other time zones. So again, thank you very much for joining.
Thank you very much.
Thank you. Have a nice day.
You as well. Have a good night.
Good night.
Thank you.
Bye bye.
Bye everyone.